You've got a series, as we have here, this sum from 1 to infinity, but instead of just having numbers and the variable n, on top of that we've got the variable x. So this is now a function of x. So I could take a value of x, say 0, plug it in, and then see if it converges using one of the various tests we have for convergence. Then I could say, well, what about if x equals a 7? Is that going to work? Well, what we do is go ahead and do one of the series tests. For this one, I'm going to use the ratio test, and we're going to have the 2x minus 5 in there. So we need the limit as n goes to infinity. So remember, with the ratio test, we have n plus 1, n for n, that's the numerator, and then the denominator is when you just have an n. Well, because that's going to be a fraction divided by a fraction, I'm just going to go ahead and invert and multiply the second fraction. So first we'd have n plus 1. There's 2x minus 5 to the n plus 1. The whole thing is divided by 2 to the n plus 1. And then divide by the fraction that just has n in it. So to divide by a fraction, you invert and multiply. And then do some algebra. And also, something that I often neglect is that this is supposed to be an absolute value. Most times I leave that off because this is positive, this is positive, this is positive, but now since we don't know what x is, it's possible that this could be negative. So you take the absolute value and then do some algebra, like 2 to the n will cancel this 2 to the n, but it'll still leave 2 to the 1. And we've got this will cancel this, so we just have 2x minus 5 to the 1. So it's going to then be the limit as n goes to infinity. There's n plus 1 over n. And the denominator has a 2. And the numerator has this thing left. Alright, now n is going to infinity, so we need to concentrate on this. This is basically n over 2n, which if you do L'Hopital's rule one time, this will become 1 and this will become 2. So we're left with the absolute value of a 1 over 2, and then the 2x minus 5 is still there. Then for the ratio test, it converges if this is less than 1. Keep in mind that if it equals 1, the test is inconclusive and you have to just try some other test. So this is a strict inequality less than 1. So this says we've got this, which in absolute value needs to be less than 1. That means we've got 2x minus 5 over 2 sandwiched between positive 1 and negative 1. And then do some algebra. So we've got multiplication by 2. And then add a 5. So if you add 5 over here, it's going to be 3. This will be 7. And then we've got that x is between 3 halves and 7 halves. So that means that this function will converge for x anywhere from between 3 halves and 7 halves. Now, back to this idea that when this equals 1, the test is inconclusive and you have to do something else. Well, if this was equals to 1, then this would be equals, equals, equals. This would be equals 7 halves. So we then have to, separately, find out what happens when x is equal to 7 halves. So you substitute that in right here, and we're going to have the series n goes from 1 to infinity. There's an n on top. There's a 2 to the n on the bottom. And then we need to substitute 7 halves for x. Just looking at this part, before I do the substitution, just looking at this part, I'm pretty sure it's going to converge, because this makes the denominator huge compared to that. So 2 to the n is much more powerful. It's going to dominate this whole problem, which means we've got very, very small fractions. All right, if we substitute x is 7/2 right here, the 2's will cancel. We've got 7 minus 5. 7 minus 5 is 2. Aha! Surprise, surprise. So this turns out, the numerator turns out to have a 2 to the n also. So those are actually going to cancel. And then what I was just talking about how powerful that was, actually gets canceled. So then this means add up n's from 1 to infinity. That equals infinity. So it diverges. When x is equal to the other side, 3/2, then we would have the same type of deal, except it's going to be, when you substitute a 3/2, it's going to be 3 minus 5 is a -2. So that's negative 2 to the n over 2 to the n. So this means it's going to alternate positive, negative, positive, negative. So you could factor out a -1 to the n from this thing. So if you rewrite this as -1 to the n times 2 to the n, then the 2 to the n's will cancel, and we'd be left with just -1 to the n. And then, of course, this n doesn't get canceled. And then this would be a positive 1 minus a 2 plus a 3 minus a 4, and that diverges. In order to converge, the terms have to get smaller and smaller and smaller. These are not getting smaller and smaller and smaller, so diverges. So that means that neither the 3/2 or the 7/2 worked out, so this interval right here is our final answer.